Hello students, today we are going to talk about something really important in physics, that is work. This topic is really important for JEE mains as two questions directly come from this chapter. We will learn this in a very easy way from basics to JEE level with examples so that you are able to solve any question that comes in your exam. So students, take out your pen and notebook and start making notes. In this video, we will learn about work, calculation of work done, nature of work done, and work done by a variable force. So let's start. So first of all, what is work? Well, generally in our daily lives, we work all day. For example, you might say exercising is work. Or when you go to shopping, pushing a cart is also work. In physics, work happens when we apply force on something and it gets displaced. Like look at this video. The engine is applying force on the car and the car is getting displaced. Look at this box. Suppose we apply force F on it and it moves displacement S ahead in the direction of force, then we say work has happened. But what if we are pushing the box against the wall? It sounds silly, right? Well, there is no work done because the box does not move. It does not get displaced. It's as simple as that. Now notice we are using the word displacement. Well, this is because, take an example. Consider this box. We move the box to a distance d, but then we keep it back to the original place. We did cover distance d plus d, but the displacement is 0. So, in physical terms, by the definition, there is no work done in this case. Now that we understand what work is, let's learn how do we actually calculate work. You have studied about work in your 9th class. When we move something with force F to displacement S, we say work done equals to force into displacement. But this is just the case 1, where force acts along the direction of the motion. Now here is the catch. For this formula, we need a constant force F. We need the object to move some displacement S, and the force needs to be in the same direction at the moment. But this does not happen usually in our daily lives, right? What if we apply force at an angle theta? Let's take case 2. Force acts on an angle theta of displacement. This is the force F at an angle theta with the displacement, and the box moved a displacement of S in horizontal direction. We can resolve this force in vector form like this: F cos theta and F sin theta, right? Now tell me, which component is actually moving the box in horizontal direction? Yes, F cos theta component. So in the formula, instead of writing F, we write effective force, that is F cos theta. The formula becomes work done equals to F cos theta into S. We can use this formula in all cases. Let's see how. Let's take an example. Imagine you're pushing a shopping cart with a force of 10 Newton for 2 meters. See here, the angle between the force and the motion is 0, right? So in the formula, cos 0 becomes 1. So work done equals to 10 into 1 into 2. That is, work done equals to 20 Newton meter. Now, how do we write this formula in vector form? Because sometimes in questions, force and displacement might be given in vector forms. We know there are two ways to multiply vectors: dot product and cross product. A dot B equals to AB cos theta and A cross B equals to AB sin theta. Here, as you can see, we have in the formula work done equals to force cos theta into S. So this is dot product of F and S. So in vector form, we can simply write work done equals to F dot S. Let's see an example. Force equals to 2i cap plus 3j cap plus 5k cap, and S equals to 6i cap plus 2j cap plus k cap. What will be the work done? Well, we will just do F dot S. So work done will be 2 into 6 plus 3 into 2 plus 5 into 1. That is 12 plus 6 plus 5, which is 23 joules. Now joule is a SI unit, which takes us to the next topic of this video, that is dimensions and units of work. We understand how to calculate work. We understand what is work. Now it's important to understand how do we measure it. Let's look at dimension and units of work. The formula for work is F cos theta into S. We know the dimension formula of force is ml and t to the power minus 2. And the dimensions of displacement is L. So the dimension formula of work is ml square and t to the power minus 2. Understood? Now what are the units of work? We used Newton meter as one unit, but in SI unit we have joule. Work done is said to be 1 joule when a force of 1 Newton actually moves a body through a displacement of 1 meter in the direction of applied force. So 1 joule equals to 1 Newton meter. Now there is another unit of work, which is erg. Erg is the unit of work in CJ system. Work done is said to be 1 erg when a force of 1 dyne actually moves a body through a displacement of 1 centimeter in the direction of applied force. Now that we understand what is work, let's explore how work can be positive, negative, and even zero. Yes, work can be zero, positive, or negative. First, let's understand how it can be positive. We know the formula of work done is work equals to force cos theta into S. We also know that when theta is less than 90 degrees, cos theta is always positive. So the work done in this case would be always positive, right? Like when you push a shopping cart, you apply force in this direction and it moves in the same direction. Angle here is 0, right? So the work is positive. Now when theta is more than 90 degrees, cos theta is always negative. This brings us to negative work. Work done in this case would always be negative. When cos theta will be 90 degrees and more, work done will be negative. Like when you play a tug of war game, work done by the team that is losing is always negative. Let's see how. This team is applying force in this direction. But the rope is moving in the opposite direction, right? So what is the angle between the force and the motion of rope? See, it is 180 degrees. So cos 180 is minus 1. So the work done becomes negative, right? Now what is zero work? Sounds absurd, right? But you can say when we take force as 0 or when displacement is 0, we can say there is zero work, right? But here is another example. Let's consider you have lifted up heavy box and you've kept it on your head and you're walking. Well, tell me, is there any work done on the box? No, there is no work done because see, the force applied by your head to keep the box lifted is in upward direction, but you're moving in horizontal direction. So the angle between force and displacement here is 90 degree, right? So cos theta becomes cos 90 degree, and what is cos 90? It is actually 0. So here the work done is 0. Understood? Now so far we've been dealing with constant forces. However, in real world scenarios, forces are variable. Like when you are playing a tug of war, if you're losing, you increase your force. So the force is never constant. Let's see how we can calculate work done by a variable force. Let's take a graph. On x-axis we have displacement and on y-axis we have force. Suppose the body moves like this from A to B and we have to find the work done. Let's take a small displacement ds. This ds is infinitesimally small, which means it is more small than you can think of. So the force acting during this very small distance will be constant, right? So the work done dw for this small distance ds is dw equals to f ds cos theta. Now to find the total work done w, we have to integrate it, right? Integration of dw is w, right? So we have to integrate this equation. The equation will become integration of dw from limits 0 to w equals to integration of f dot ds cos theta. What will be the limits of this? Yes, from A to B, because ds is from A to B. So we put in those limits. In the questions, this f will be given in terms of variables and we will just have to integrate it. It's that simple. Notice the work done here is equal to the area under force displacement graph. Hence, we can expect such types of questions in JEE level exams. We hope that you have understood the concept of work. Now, here's a secret on how you can study effectively with EduRev app. You can learn with chapter notes, watch video lectures, and solve JEE level MCQ tests of this chapter on EduRev. And that's not all. You also get amazing courses for physics and much more for your JEE preparation. Thank you.